So if you've ever played any of those games, TV games that involve characters, cartoons, and all of those things, they are using matrices. Another thing is also if you've ever also used GPS, GPS, and those Google Maps and all of those things, they're able to tell you the position, the location, and all of that. It's still based on matrices. Another thing also may be some other, like programming, coding, all of those things. They will still be moving around matrix. So even in economics, there's still matrix there. Now, you could, as we progress, the advantage of our matrix is that it's able to do something that is very small in a very big context. For example, as we go on learning, you notice that we'll just be learning very simple things that you know already. You see us learning about, let's say, how to solve simultaneous equations, and this time around we'll be using matrices. Then another thing may be also learning how to do reflections, rotations, and transformations. Do you remember that thing in JHS? So let's say we are rotating something on the x-axis, you are going to get this. You are rotating any tissue. If you are rotating something on the y-axis, you are going to get that as well. So the question is that why do we have to learn matrices if we can just use all those very normal things? The reason is in the simultaneous equations that you know how to solve, you are just going to be solving for two equations. Imagine you are supposed to work with, say, 50 equations or 80 equations, or let's say even a million equations. You can give to me. Let's even say a million equations. How are you going to go about that? That would be a lot of work. I you know what I'm saying? So now you're looking at 100 equations, and then you still have to produce an answer. That would demand much more than just solving the equations that you know how to solve, or how you solve equations in JHS. Or let's even say you're supposed to rotate and transform something. You have to rotate them at multiple angles. Rotate the thing at 45, reflect it at x on the x-axis, on the y-axis, and stretch it. So that's how the cartoon things work. They are either rotating a character, they are either stretching it. So if a character moves from, let's say, this point to that point, it's not just the normal thing, in the normal one we can do in JHS. We are just going to rotate the thing like this, and that's all. Or let's say it can reflect something like this, and that's all. But here's a case where the thing is moving, rotating, doing all manner of things. That would mean that a lot of information is being run through the system. So in this case, you'd have to use matrices, because matrices have the ability to scale up basic concepts into a way that can handle very huge numbers. I hope you're getting what I'm saying. Are you following? Yes, sir. All right. So